going to practice a few questions on random variable and its probability distribution. So that's the point of today's thing. Now the first question is value of a random variable always positive real numbers. You can watch this at like 5 or 1.75x speed because this is not the ideal. This is only for my self practice. Can be considered a way of streaming or whatever, but it's sort of that only. So can be considered that if nothing else. So yeah. Okay. Yeah, so it does not necessarily have to be positive all the time, and real numbers is also like very constructive because see, real numbers are numbers that are placed on a number line including a positive, negative, fraction, irrational. It has every kind of number. Now always a positive real number would be a gross simplification, which is not the case. Like here, if you win $5, then x is 5. If you lose, then x is -3. In this case, the random variable can be a negative number. Similarly, in this case, if temperature drops by 2 degrees Celsius, y is equal to 2. If it rises, y is equal to 5. It can be positive, negative, so nope, it's false. Okay, for a negative random variable, variance of x must be positive. Again, so variance of x is somehow like this or something like this. So not probability of x, but like f of x also. So that is not necessarily always going to be positive. So I think this is also false and this is false only, correct. Okay. Now if ex is a negative, x must be positive negative random variable. Must be, it's not always cut to cut that it should be that, so I will go with false, and false is the correct answer. Okay, if expectation of this is this, no, yeah, I think, yeah, no, wait, I have seen this before. Wait, wait a second, I've seen this before. Okay, so the whole point is they're independent, then this is equal to 0. Yeah, that is covariance of xy is 0, not expectation of xy. These are rules of expectation, so no. So this will also be false. Okay, if x and y are independent random variables, uh, oh wait, I did it wrong. Wait, sorry, my bad. This is it's true. Oh, it is equal to, okay, yeah. Sorry. If this is equal to this, that means the sum is going to be negative, and those covariance is negative. So yeah, it's true. What I was after even. Okay, yeah, that's true. Okay. If x and y are independent random variables, then variance of x and y, x plus y is variance of, yeah, that's true. Okay, if correlation of x y is 0, then variance of x, if correlation is 0, then yeah, I think true. Yeah. Okay. The first now. Okay. Yeah, this is something that you can now probably get. So it says for a random variable x, ex is always exist. Not necessarily. It is false. It is false. Now covariance of x and y is always non-negative. Cannot always be non-negative. It can be, because see, when we say non-negative, yeah, it's not non-negative. It can be negative. Covariance of x and y 0, then x and y are independent. Why not? Isn't that what we just discussed? If covariance of x and y is equal to 0, then x and y are independent. True or false? Okay. That implies that, but that does not imply that, is the situation what I'm understanding here. So yeah, this will be false. Okay. Okay, if expectation of x is 3, expectation of y is 9. Wait, I'm doing something here. Wait. Okay, yes. Okay, yeah. It will be 9 minus 25. Is it 0? It is 0. Yeah, it is 0. Okay. The variance of a standardized variable is. The variance of a standardized variable is dash. Okay. It is a 1. X and y are independent, then covariance of 2x and 3y. 0. Okay, if expectation of x is 5, this is 44. Wait. I'm solving it on my paper, so you can maybe skip this. Okay, I think I figured it out. It's going to be it's quite complicated, wait. Go like expectation of x is equal to 5, expectation of this is equal to 4. Okay, this is what is the question. It's 44. That makes things better, yes. Yeah, then it makes sense, yeah. Sorry. Yeah, okay. So this becomes ex square minus ex 44. This I will use here, then this will become 49 x square. Variance of x will be 49 minus 25. Out on what will be this? 24. Then 24 into 4 will be 96. And that's my answer. So yeah, that's my answer, 96. Very good. If random variable of x assumes two values only, minus 2 and 1, that p okay. The expectation of x would be first I will use this. This would be 2 into px minus 2. Then this would be minus 2 into p of minus 2. This would be 0. That's the answer. Zero. If x and y are independent variable, with a variable of x is equal to 6 and variable of y is equal to 10. Variance of y is x is equal to 6 and variance of y. variance of x minus y is 16 because a very important property to note indeed. I'm also writing in my book. If you want to write, you can also write. Nobody is stopping you. Yes, now moving on. Okay, if expected value of sum of points obtained in two throws of a fair die is expected value of sum of points obtained in two throws of a fair die. This was 7. Wait, I will do this later. This is a very big proof which goes a bit not so big actually. If you want, I also do. So the probability distribution of a die would be 1, 2, 3, 4, 5, 6, 1 by 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 6. This would be my x and this would be my p of x. So expectation of x would be x into p of x. So I'll get 1 summation 3, 4, 6 into 1 by 6. Doing this will result in 7 by 2. Now what I have done is I've done this twice. So I'll add this for my twice. This is my total. That would result in 7. So yeah. Okay. If the x denotes number of heads obtained in 3 tosses of a fair coin, then ex is right. Wait. Single coin is tossed thrice, right? So this would be okay. If it was otherwise, then it would have head, head, head. Then it would have been a different thing. Okay. Okay, now if x be a negative random variable with variance k, then we must have I have no idea. If x is a negative random variable with variance k, then we have 4 options: a k less than 0, b k greater than 0, and c k greater than equal to 0, and d none of these. It will figure it out, don't worry. Great, then where did we do it? Wait, I remember something. Wait. Isn't this here somewhere? Wait, I'm trying to find it. For a negative But then there was a statement which I did in true and false, according to which for a negative random variable x, variance of x must be positive, and that statement was false. It still doesn't answer my question that y is for a negative random variable, variance of x must be positive is a false statement when variance cannot be negative. So that means my statement is true. Oh, so it says positive. By positive, okay. So there's a difference between positive and non-negative. Okay. Non-negative is 0 plus positive. Positive is only positive, no 0. Okay. Makes sense. So this will be kind of a realization for me. If random variable y assumes values 0 and 1 with respective probabilities q and p, then variance of y is equal to pq. Right now, okay, if a random variable that takes value 2 with probability 1, then variance of z is equal to 2 probability 1. A random variable z takes value 2 with probability 1, then variance of z equals 2. I think variance is equal to this, right? So when we will do this, we will have 2 minus 2 is equal to 0. Is this what it does? It does what that only. Wow, okay. Yes. Okay, alright. If random variables x and y are independent, ex is equal to 0, ey is equal to 5, then variance of x is equal to 10. Wait, I'm figuring it out. If they're independent, so there is no relationship between x and y whatsoever. So it's going to be ultimately variance of x only, which we have. This would mean I want to say independent, but I don't think they're independent. It says uncorrelated. So okay, this property is worth a discussion, definitely. But right now, for our purposes, this video is done. What I will say is thank you for watching. Most likely I'll post another one tomorrow. So have a good day.